next I want to talk about some properties of the normal distribution. So let's take a look at this example. So pulse rates of randomly selected adult males have a distribution with a mean of 70 beats per minute. So we're going to use the Greek letter mu to denote a mean, and the Greek letter sigma to denote the standard deviation. And the standard deviation is about 11 beats per minute. Can we consider this a normal distribution? Yeah, heart rates are something that occur naturally. So what I want us to do is I want us to go ahead and draw this normal distribution. So here I have my normal curve. I've got my mean in the center, which is 70. Let's put a few standard deviations on each side. So I've got 81, that's one standard deviation. 92, that's 2 standard deviations, and 103, that's 3 standard deviations above. But we also want to always go 3 standard deviations below. So it would put me at minus 1 standard deviation gives me 59, minus 2 gives me 48, and minus 3 standard deviations gives me 37. So here's our normal curve for the pulse rates of adult males. Okay, so like I said, sigma means the standard deviation and mu means the mean. Right here we have the region within 1 standard deviation of the mean, because we go -1 or +1 standard deviations above or below the mean. And we can use these standard deviations to tell us something, kind of a general rule about our normal distribution. And that is the 68, 95, 99.7 rule, okay? This rule gives us the guidelines for telling what the area is using standard deviations. So for example, about 68% of data falls within the first standard deviation. That means this area would be 0.68, 68%, 0.68 is the proportional area related to that. About 95% of data falls within 2 standard deviations, so the area under this portion of the curve would be 0.95, and 99.7% of data values fall within 3 standard deviations. So this area would be 0.997. So let's use this 68, 99, 95, 99.7 rule to solve a couple of problems. So tests that make up the verbal and mathematics SAT are designed so that their scores are normally distributed with a mean of 500 and a standard deviation of 100. Let's interpret this statement using percentages. So I'm going to go ahead and draw a normal curve. My mean is 500. I want to go up 1, 2, 3 standard deviations. And I want to go 3 standard deviations below. So that puts me at 600, 700, 800, 400, 300, 200. So let's interpret this statement using percentages. Let's look at the first standard deviation. Well, within first standard deviation, we have 68% of data. So I could say 68% of scores, right, because our data is test scores, fall between 400 and 600. Now I can look at the second standard deviation. Well, I know that 95% of data falls within the first 2 standard deviations. So 95% of scores fall between 300 and 700. And last but certainly not least, I can look at the third standard deviation. I know that that holds 99.7% of data. So I can say that 99.7% of scores fall between 200 and 800.